Okay, today we're going to go over a case study. The vehicle is a 2003 Ford Crown Victoria with a 4.6 liter, and the customer is complaining it runs rough. As you can see, this is one of the campus police cars. So we're going to start by identifying the vehicle on our scan tool and checking for codes. The first code we identify is a P0356. This is an ignition coil primary or secondary circuit code. So it's important to understand that this is a circuit code, not a performance code. As we said earlier, the vehicle is running rough, so our next step will be to do a power balance with the IDS scan tool. And as you can see, we quickly identify that cylinder number 6 is misfiring by that dip down in our power balance graph. As we talked about before, we might want to look at data to determine if we have an ignition or a fuel misfire. So we go ahead and look at some data, and we can see right away, and I'll zoom in on it right now, our short-term and long-term fuel trims are all zeroed out. It's not giving us any information here. We can also notice that our oxygen sensors are all very lean, low voltage. So all the rules that we've learned so far about looking at oxygen sensors post-cat, looking at fuel trims to determine what kind of misfire we have, aren't working for us. One more piece of data that's on the screen, if I scroll up, is that the fuel system status is labeled as open loop fault. So the fuel system status is currently labeled as open loop fault, and we will learn a little bit more in this class about what that means, and we'll see it more in this case study here. Next step is we're going to go ahead and hook up our oscilloscope. We're going to scope primary voltage on ignition coils 5 and 6, and we're also going to scope primary current. One thing you need to remember is our primary voltage could be in excess of 300 or 400 volts, so we're going to hook up our attenuators in line to our primary voltage circuits. You can see we went ahead and remove the fuse for the ignition coils. We put a fuse jumper in and put our current probe there to gain current for all 8 ignition coils. This is the first pattern we pick up. You can see we have our number 5 primary, which is what we're going to zoom in on right quick. And this is textbook perfect primary ignition. But as you remember, number 5 is not the cylinder we're having an issue with, number 6 is. So we have something to work off here, something that we should see now as our number 6. But as you can see, if we move over to our number 6, we have nothing really. We have nothing in the primary circuit. So let's zoom out real quick and also take a look at all the ignition coil currents in green. As you can see, again, cylinder number 5, our known good, looks normal, but we see something abnormal on cylinder number 6. We see the current peaking at about 13 amps, where our other coils are really peaking only at about 6 amps. So we tend to have a real big issue here. I'm going to go ahead and blow up and zoom in on the number 6 coil. As you can see, nothing really going on in the primary circuit, and we get these little spikes in the current. So what this vehicle has is a shorted ignition coil. As your resistance in that circuit goes down, your current's going to spike way up. Now, just to prove a point, I went ahead and measured the resistance of the old coil, and I also measured the resistance of the new coil. As we've talked about many times, using your ohm meter to test resistance of ignition coil is almost a worthless test. If we were to calculate out the true resistance of this circuit using Ohm's law, we would find that since it has about 6 amps flowing through it and 13 volts or so, that the actual resistance, the dynamic resistance of this ignition coil is somewhere around 2 ohms of resistance. We really don't see too much of a difference between our old coil, which is here at 0.2 ohms, and our new coil, which is here at 0.6 ohms. And we know now that this new coil is going to be at about 2.2 ohms of dynamic resistance. So, in summary, don't use your meter, use your scope. So we got our new coil installed here, and we're going to go ahead and do some testing here. I went ahead and reset, or I'm sorry, I cleared the codes and also did a cam reset. So keep alive memory, it has been reset. Fire up the car, it's running a heck of a lot better now, and we check our power balance graph, and as we can see from our power balance graph, everything's nice and smooth, nice straight line. Well, let's check our data again, because as you recall earlier, that data was all zeroed out, and as you can see, we have some fuel trim activity. We got negative 2.45 and negative 1.49 as our short-term fuel trims. We haven't learned any long-term trims yet. You can see our fuel system status has gone back into closed loop, and our oxygen sensors are switching. They are all happy, and it's all good. Well, one last check here. Let's go ahead and triple check with our scope, and as you can see, all the ignition pattern came back. We got primary voltage, we got our primary currents. I'm going to zoom in on cylinder number 6 again, and it's just a beautiful picture perfect scope pattern now. Current ramps the way we should have them. Primary voltage looks beautiful. So this car had some really crazy issues with it. It was running a lot worse than having just a single cylinder misfire. So the question is why? Well, when we saw that open loop fault earlier in the case study, you can see that this ignition cylinder code actually will shut off the fuel injector and go in open loop fault. We stopped using our oxygen sensors for feedback, and it caused the entire engine to run rough. So I know we've learned about using fuel trims and oxygen sensors to determine if you have a fuel or ignition misfire, but they're only accurate to a certain point. We have to be careful, make sure the injector is not shut off. We have to make sure we're not in open loop fault. Thank you much.